Well, hi, my name is Teresa, and today I'm going to talk to you about programming for people. And so recently I read this book called Cities for People, which is about how architectural design can be used to change the culture of a population. And more specifically, it talks about the transformation in the 80s of Copenhagen, which is where I'm from, and the change that it underwent in terms of like going from being a car culture and into a bike culture. And so, illustrations, great. So I am going to be talking a little bit about bikes and cars, but bear with me, it is actually also about programming. So let's talk about car culture for a second. So one thing that a car person might say is that, oh, there's so much you can do with a car. It can take you across borders as easily as it can go around a corner. And you can go on road trips, which admittedly are actually really great. I went on one like a year ago in America, and I feel like I know what freedom is now. And another kind of freedom is like you can go to IKEA without any trouble. In Copenhagen, I only have my bike, and when I go to IKEA and I buy a shelf, I just have to put one side into the basket and the other side on my shoulder, and I just have to risk my life for like an hour. And so like it's not a great experience, but like with a car, you can just pop it in the trunk and you're good to go, or at least that's what people tell me. So yeah, but a bike person might say some other things, like they might say, look at these legs, get so much exercise, I'm really excited about that. Or you might say, okay, I'm so good to the environment, I have no pollution or no noise, and just don't worry about the self-driving bikes here, Google's got it under control. But ultimately these are not like, it's not like there's a right or wrong here, it's just different values of different things. And you see a similar reality in terms of front-end programming. On one side you have JavaScript, and a JavaScript person might say, oh, you can do so much with JavaScript, and you have so much freedom in terms of like if you have a problem, you can solve it with functional programming, you can solve it with streams, you can solve it with object-oriented programming, you can mix and match as it sees you fit. And this flexibility makes it a really good choice for prototyping. Because you can just like, if you want something, or this value needs to be this thing, okay, I'll just mutate it, it'll be fine. You can leave out these holes, which you can fill in later. And there's this really great community in the JavaScript, and you have all these resources, so like there's a lot of packages that you get shared, and you don't have to build things from scratch ever, basically. Now, there's another side, which is Elm. And so Elm is a programming language, which I've been working with for the past 2 years. And it is a programming language that compiles to JavaScript. And there's a lot of familiar things that you know from React, for example. So it has a virtual DOM, and it has like a single source of truth kind of thing, and has routing and all the like normal SPA stuff. But it has a very different value system in terms. So like something that a Elm person might say is that, oh, we have no runtime errors, that's really exciting. Like, no JavaScript person will say that because it's just not true. In the same way, like, okay, one might say as an Elm person, like, oh, I'm really excited how there's only one way to do things. And that's like also not something a JavaScript person would say because, secondly, that's also not true, but it might even sound bad. It might sound like, oh, you're gonna put me in some prison, like programming prison. But so again, there's not really a right or wrong here, it's just different values. And what's cool about this book is that it explains sort of like some tools you can do to change culture over time and some kind of transformation. And because it does take a transformation, because you can't just have like, you can't just say to Amsterdam, okay, now you all like cars. And it's just like, no, because we don't. And so it has to be a slow transformation. And one of the things you can do to change a car culture into a bike culture is that you can make it safer for a bike to go outside. That's one of the things. So one way to do that is that you can add speed bumps. That will slow the cars down and kind of make it annoying to drive a car as well. But it'll be safer. We're not building for the cars anymore. We're building for the bikes. And so we're building for a different set of values. Similarly, you might like build some parks, so it's nice to bike outside. And there's like, I'm sorry for the look of these speed bumps. I'm not a construction worker. But in a similar way, there are speed bumps in Elm, which I'm going to talk a little bit about now. So on the list of those, so a problem that would make life better in terms of the values of an Elm person is like, okay, in JavaScript you have all this like, when you try to find out what's going on, it's like you have a value that's being mutated over here, and then it's like it's going through some functions, but then another function mutates that, and that can be really confusing for someone like me, for example. And so one way to solve that is like, okay, well then you're not allowed to mutate at all, which is the case in Elm actually. And secondly, another thing which I'm guilty of is, in particular, is like when I have, for example, a HTTP request, and in my head, I only imagine the happy path, and I'm like, I like can forget entirely to deal with the error messages or like the bad situation, and I'll be like, maybe I will just be like, nah, it won't happen. But what if we just didn't have that happen? And that's the case in Elm. Like you cannot skip out on error handling, which maybe needs a little more explanation. So let's say we have that HTTP request. Say it's supposed to get a user. And the result of that HTTP request can be either a success, where you get the user, or it can be an error, where you get an HTTP error back. And this is actually how you would model a HTTP request result in Elm. So it would look like this. You have the type as the result, and you have an OK state, where you get a user back, and an error state, where you have an HTTP error back. When you work with this result, you always, thank you, you always have to take care of all the cases. So if you see this case statement, it's kind of like a switch in JavaScript. So, but if the thing is that if you forget to take care of one of the cases, or just like, you're just like, nah, Elm would be like, hey, you need to account for the following values. Please eat your vegetables. And this way, what's interesting to notice is that Elm doesn't really remove runtime errors in this magical way. It just goes in and finds out for you where there would be runtime errors and be like, hey, this you gotta look at this and make sure it doesn't happen. And another thing that I personally found frustrating when working in JavaScript is that we once had like this big React application, and it was before all of the like Flux and Redux stuff, and so there would be like it was built with Backbone and React, and then my colleague got really into streams, and he was like, oh, let's work with streams, and yeah, like that's a great idea, let's do that. And then now we have this streams thing and this Backbone thing, and then Redux comes out and it's like, I really like Redux better, so now I'm gonna do Redux. And now we have like 4 different ways to manage state, and it was very difficult and confusing. And so in Elm, what is really cool to solve that problem is like, okay, well then you only have one architecture to solve all problems. And I can talk a little bit about that. It's called the Elm architecture. And it is actually so great that, that it was adopted in a lot of other languages. Actually, it was also adopted in JavaScript, for example. Redux was directly inspired by Elm. And so if you find it familiar, then that's probably why. So it starts out by having you have this initial state. Model is the name for a state in Elm. And you add it to the view, and the view knows how to show it, and it's all good. When you interact with the view, all the interaction comes out as a message describing this interaction, and it goes into the update function, which knows how your state changes based on these messages. And so it sends back a new state, and it views it, and you have this sweet little cycle, and it's great. But you might be thinking, what about that HTTP request? How does this fit into that picture? And that's a good point. When you have a server, what you can do is that you can send a command and saying, I want this data, and then it will send back a message, which the update function now can understand, and then it updates the state and sends it back, and you're back in the loop. And that's how you deal with all the effects. And this is how all Elm programs work. So when you know one Elm program, you can read all Elm programs, which is pretty neat. Another thing is that sometimes when you go on NPM, you might find a package, and you're like, oh, this is really exciting. It looks like it solves my problem, but you try to use the API, and you're like, it doesn't exactly describe what you're trying to do, and you're like, what's the options for this function? And you have to go look in the code because it's not properly documented. And in Elm, this just cannot happen because you have to document all your functions if they're exported in packages. And it works in a similar way to the HTTP request with the error messages. So say you have a module that exposes a pluralize function, and if you try to publish this package, then Elm would be like, hey, you gotta eat your vegetables. You gotta add a documentation function to this. And so it will go away once you add documentation to it. You can also leave this blank, but then you're making an active choice to be an unkind person. And, well, that's up to you. But you'll never forget accidentally, which is the point. And so lastly, one thing that can happen to you in a JavaScript world is that you can update a package that was a patch, and then, surprise, it's not a patch, it actually breaks your build. And you can't do that in Elm because it looks at your API and actually checks with the previous versions whether you break the API. And if you do break the API, then it's a major change. And so to go back to bike world, we can take a look at how these speed bumps changes the world. And there are some pretty obvious changes that happens when you have speed bumps. Is that, okay, it'll become more popular to bike, but that's not always it, actually. That's not only it. What happens is also that when you bike, you are slower than the car, and you have more time to observe the cityscape. And so what happens is that you actually give a motivation for your surroundings to become more detailed. And so what happens in cities where you have a strong pedestrian and bike culture is that the city will actually become more colorful and detailed. And which is funny because before I would think that that for 200 years ago cities looked like the way they do because people like that style. And now we're all into minimalism and stuff, but really it's partially also because people just move slower through the city and they have more time to observe the details. And so in a similar, you can see the opposite trend actually in a lot of American cities which are surrounded around car-centralized culture, and you see that cities actually become way more blank and boring, and all you have left is these very large billboards because people can't see anything else, so there's no point in having it. And so when you have this bike culture, because everything is interesting to be outside, you will actually lure people out into the street as well. And people will meet each other. So actually what this can do is that it can lower crime rates as well because people actually create a community together. And so yeah, rainbows and sunshine everywhere. I'm kidding. Bikes don't actually change the weather, although that would be really great. But in the same way in Elm, you also have rainbows and sunshine. No, we just have no runtime errors, but that's also pretty great, to be honest. This, as explained also, is because Elm goes and finds all the places where there would be a runtime errors and let you know that you have to handle an error here. And debugging also becomes a lot easier because, when you're debugging in JavaScript, you might have again, this mutation. It's hard to keep in your head where everything goes. Oh, what order was these changed? And in Elm, because everything is pure functions, everything is just data transformations one after another. And if something goes wrong, you could just go a few steps back up and be like, oh, I know exactly what happened. And so that's pretty great. Another thing is that because there's only one architecture, it's really easy to orient yourself around your application, because again, once you know how to read one Elm program, you can read all Elm programs. So as mentioned, I work at NoRed Inc., and at NoRed Inc. we have more than 200,000 lines of Elm code. And so, of course, I haven't written all of it, so lots of the pieces are new to me, but every time I go into a new place, I always know what's going on already, because it uses the same patterns as what I'm familiar with already. And this is also a huge advantage for our new hires, for example, who are not familiar at all, because they always prefer working with Elm because they can basically not mess anything up, and they only have to learn one pattern in order to understand everything. Another thing is that, for the same reason, package management becomes really easy, because all the packages are also the same architecture. So whenever you have a package, it will always fit directly into your architecture, which is pretty neat. But there's one thing which I found the most surprising about working with Elm, was that I spend my time completely differently now. Because I don't have to spend time tracking down error messages in the browser that happen in production and finding out strange mutation patterns. I actually spent my time designing what is unique to the application I work on, which is my data structures and my logic, and to create really nice APIs for me and my colleagues. And I find that to be the most rewarding part of programming. So I know what you're all thinking, is that in a city filled only with bikes, how do you deal with ambulances? Bikes are extremely poor choices for ambulances. You have how would you even do that? Would you do it with the shelf where you put the legs in the basket and it just wouldn't work. The point is there are realities which don't really fit into our sunshine world. And for example, when talking about programming, we have you might have a huge React application, and you're there's no way that we can just change everything to Elm just because we don't want to run time errors. There's be some middle way. But that's actually okay, because in Elm, if you remember this diagram, so just to recall, there's a view, it sends messages during any interaction, it updates the state, and it comes back into the view, and you have this cycle. And if you remember how you can do commands and send it to the server, well, you can also send commands to JavaScript. So, and JavaScript can send messages back into Elm. So this means that you can also embed an Elm application into your React app and have them talk, and you can just make JavaScript do whatever you like. Actually, you can do mutations or anything you want, any library. And so, yeah. I imagine you only have one other question in your head, which is, oh, but bikes only have 2 wheels. I actually don't think you think about that. But it is a reasonable question if you imagine a person only coming from a car culture, because it's a good metric to measure the quality of a car. So a car, if it has 3 wheels, that's probably a pretty bad car. And if it has 2 wheels, it's probably even worse. But in the same way, there are some metrics in JavaScript which are not really applicable to Elm in the same way. So the first thing is like, okay, there's a JavaScript person who sees an Elm program might be asking like, oh, there's so many lines of code. And there's actually a really silly reason for that, is that there's this formatting tool that everybody uses, which is like really loves white space. And it's just like every like 10 characters, it puts it on the next lines or something like that. Well, that's not entirely accurate, but it adds a lot of white space. So that's actually the main reason. If there's any more code, then that's because you have to spend time like handling errors, and that might be the only thing. Another thing is that, okay, you have, when you come to Elm as a JavaScript person, you might be concerned with the size of the ecosystem. It's like, oh, I'm used to having like millions of packages, but like, you only have 1,500, and that's correct. But it's also worth remembering and keeping in mind that Elm only has one way to do things. It has one architecture, which drastically limits the amount of variations you can get on a solution to one problem. So, for example, in Elm, in JavaScript, you might have like 40 child libraries, but in Elm, we only have like 3 or 4. And that's just because there's less way to do things, and it's a smaller subset. And lastly, there's like a JavaScript person might look at Elm and be like, oh, but it's the releases are so far apart. Like it hasn't been a release for 1.5 years. Like, is Elm dead? And that's a reasonable reaction to have for if you're dealing with frameworks. Like if you are considering using a framework and it hasn't been released in 1.5 years, you might want to be concerned, and you might want to be like, is this framework dead? Should I use it? But what's also worth keeping in mind is that Elm is not a framework, it's a language, and it's actually a good thing if a language doesn't change all the time, because you want to have a stable platform. So yeah, those are like more general cultural differences. But there are other things that you might run into with working with Elm. So with biking, though, you might ask yourself, it's so freaking cold outside, like how do you bike in this weather? And I didn't make this up. I actually have a friend from Texas who came to join me in Copenhagen during the winter, and you get a bike there and it's all good. But he in Texas, you don't have cold and you don't have bikes. And so he didn't know, he didn't have gloves and he barely had a jacket, and it's like, how do you survive this place? And it's like, well, dude, you gotta wear gloves. and so there are things that are obvious to if you grew up with a culture, but it might not be obvious when you just transition from a different one. And so, of course, there'll be questions if you transition from JavaScript to Elm, but there are places where you can get your answers solved. So one place is the Elm Slack, for example. There are lots of helpful people, and I personally, when I first got started with Elm, there's a really nice beginner channel, and there are no stupid questions, and you can ask whatever you want, and you'll get help. And there's tutorials. And my favorite one was the official guide, actually. And it goes through from the very beginner to the advanced, how to build an SPI fully. And so I can recommend that. A third option is that you can come work at Nerd Inc. and you'll have an entire team ready to teach you anything you need to know about Elm. And so we have gone through all of how to transform culture through different designs, but ultimately one might ask why does biking feel so good? And that's very hard to describe, but you can go to elmline.org to find out. That's it.